increase the height here just a... Nope, that's as far as it goes. All right, well, so it goes. Maybe if I scoot you over just a little bit, I can get better. Whatever they call that, keystone, keyframe, whatever. There we go. All right. So test 1 is going to be held February 13th, which is a Friday. Oh, my most sincere and humble apologies for putting a test on Friday the 13th. I know, it was unavoidable according to the schedule. That's the last day before reading week, by the way. So yeah, that's when our first test is going to be. It's going to be a pen and paper test. You will not be allowed any aids. There will be a reference sheet attached to the back that you can detach that will have some of the methods and references for the objects you will use, particularly pertaining to the JavaFX library. But yes, there will be a test. We will write a test. It will be held during class time, during our regularly scheduled class on the Friday. And any questions? Yes?
This is just a question about assignment 2.
Yes.
What are you going to be releasing it?
Assignment 2, we will be introducing today. And code review will be next week, Friday. And it'll be due the Sunday after that. Sound good? Very good. Any other questions? All right. Well, we've got a lot to get through, so we might as well get to it. Boink. There we go. So the due date for assignment 2 will be February 8th. We will be, so the week of the test, right? The class before the test, we will, I am intending to hold a test review. Now, I know it's like, not necessarily the best to have the review so close to the test itself. Unfortunately, it's what the schedule gave us. But that's what we're going to be doing that week. For our first class of the week, second class will be the test. Okay? Sound good? Very good. So, assignment 2 then. Assignment 2 is more work than assignment 1 was. But don't let that discourage you. By the end of certainly tomorrow's class, you will certainly have everything you need to know in order to perform the assignment. So, you will make some classes in Java to reproduce the functionality of a vending machine. Now, this will not be a graphical application. This will be a command line interface. So, essentially, this thing divides into 2 parts, right? You have a class modeling, a class modeling the thing that we are, like the software artifact that we are trying to replicate, right? The thing we are making. We then have a module called the view, which functions as the user interface to that object. Question?
So we'll have 2 different classes.
Mm-hmm.
The view one is the one we'll run from the start, right?
Yes. So the view contains your main method, right? So this is an important, shall we say, one of the formal learning outcomes of this course is that you understand the difference between a model and a view, right? So all of the logic that has to do with the operation of the vending machine, in this case, that is model material, everything that talks to the user, receives input from the user, that is view material. The model and the view communicate with each other by the view creating an object of this class, calling its methods, and using its return values. This is how APIs work in Java. You create an object, you call methods. Make sense? So far, so good. So, a couple of good rules about the view model distinction. If you have even a single instance of system.out.println inside the model, you've done it wrong. Okay? All printing to the console must occur through the view. But you may say to yourself, but Mr. Professor, sir, certainly error messages or messages of some kind would originate in the model. It's natural to print it. Why wouldn't we print it? How are we not passing strings around anymore? And the answer is, yes, you are passing strings around, but you are doing so as strings, right? You're not printing things directly from the model. You're passing the string forward to the view, and then the view prints it. Or perhaps a bit more accurately, the view chooses how to print it. A view is not necessarily a command line interface. Views can also be fully fledged graphical user interface programs, GUIs. The Java FX that we've been learning so far, we will eventually use in this course to construct views. We're not quite there yet. So far, we're content to do things inside of the command line interface, right? Command line interfaces have certain advantages over graphical user interfaces. They're a little bit easier to develop initially, so it's good for learning, even though they're not as flashy. I mean, unless you put a lot of points into your ASCII art, but even so. Does this make sense? Model view distinction? Yeah? Thumbs up? Thumbs up. I'm getting 2 thumbs up. 3 thumbs up, okay. That's not majority thumbs up. Oh, 4? 5? Okay. I think we've hit majority thumbs up, so I'm good with that. So yes, in terms of concrete deliverables, for this assignment you will be writing and submitting 2 classes. So, step 1, the first step, is to work out your design. There are 2 approaches to creating design documents, the good way and the bad way. The good way is to figure your design out before you start coding, and then you know what you're coding. The bad way is to start coding first, make your implementation, and then document what you've already done by writing a design document, right? So you want to start with your design, right? You don't want to start with the implementation. You should do your prep work before you start cooking, right? You should chop your celery before it's in the stew, right? Does that make sense? So, somewhat? Well, we haven't talked about UML diagrams yet in class. We'll be doing so today. But essentially, the way that we're going to teach you to design object-oriented programs is using class diagrams. Class diagrams in the universal modeling language, which is not universal nor is it a language, but it does model things. So it goes. So, let's describe now what the vending machine is and does. What properties does it have? A vending machine contains a single type of product. The product has a name and price, and there is a limited quantity available. A vending machine tracks its current unused credit and the total amount of money it has taken in since it was switched on. The product name, price, and quantity can be set when the vending machine object is created, or the object can be created with default values for some or all of these attributes. We'll get into what all of that means. A user can put coins into the vending machine one at a time. The currency is Canadian, and the vending machine can accept loonies, toonies, quarters, nickels, and dimes. Those aren't in order of magnitude, which kind of bothers me. That's okay. The user presses a button to vend the product. Presses a button means calls a method to vend a product, and will expect a response. Either something is vended, something is vended, something vends, an item is issued forth from the product, or it doesn't, right? Imagine you're at disclaimer, I highly do not recommend drinking soda pop, it's terrible for you, right? But at a soda machine, right, this is like your analog, right? If you put, 3 nickels into the soda machine and you ask for a Coca-Cola, it's not going to give you the Coca-Cola because you haven't entered enough coins to pay for the item that you want vended, right? So asking to have the item vend, pressing the button, is an operation that can succeed or fail. Make sense? So far so good? All right. The vending should be denied if there's not enough credit in the machine or there's no product left. It's up to you how to handle the user's change. The machine might automatically return it when the vend button is pressed, or it might just deduct the price and leave the remaining credit. Either way, there should be a coin return button that will return the credit to the user. Again, button means method. Hello. When the machine is first turned on, it is initialized with the name, price, and quantity of the product it contains. There are no restrictions on how the user may use the machine. They can insert their money before they press the buttons, after they press the buttons, or even while pressing buttons, in the middle of pressing buttons. There should be a toString function that returns a full report, something like the following. The vending machine is the model, that is the brain of the actual vending machine. The model should never talk to the user directly. It should do no input, it should take no input, and produce no output. Except, I hate that sentence. It should take no input from standard input from the command line interface. It should produce no output. It should print nothing to the command line interface. Instead, it should pass strings forward to the view whenever that's necessary. Make sense? Good. Step 2, implement the vending machine and break room classes. So, once the class diagram is finished and you've implemented your vending machine, note this is recommending implementing the vending machine first. Good recommendation. A lot of the time with these types of things, you want to proceed from small things to bigger things, particularly when the bigger things are made from the smaller things, right? you are to write a main method in a different class to simulate a user interacting with the machines in the break room. This method should create 2 vending machine objects and allow users to interact with each one using a menu interface, such as this. You are given an example of what the output might look like. All right? You are in no way, you are not required to exactly produce this text output. All right? You have some degree of creative freedom, how it is you want to, do your interaction. But it should do all of these things. Does that make sense? In particular, at the very least, you should pick your own things to go in the vending machines, right? So, make sure to encapsulate your instance variables with appropriate get and set methods and a to-string method. At this point in the course, it is not required to use constructors for this assignment. Don't forget to follow the documentation standards for the course. So, submission via the usual mechanisms. Are there any questions about assignment 2? Some of the stuff here we haven't covered. We will be covering a lot today. Question?
So we're only allowed to have 1 item in each vending machine, right?
That's right. So, if you decide to meet the requirement to have 2 items by duplicating the item variables inside of the vending machine class, that is an error, right? This is actually attempting to get across a very important point about object-oriented programming. You write a class so that you can duplicate functionality, right? You don't declare the variables once for each variable that you need, right? If I need 2 items, 2 vending machine items, I need 2 vending machines, right? So you declare 2 vending machines, you configure them to have the right items. You don't write 1 vending machine with methods to access both different item types. Even though that is technically a type of vending machine that, there are multi-item vending machines absolutely that exist. In fact, a vending machine that only vends 1 item isn't much of a vending machine actually. They usually have at least 10 different types of pop in them, right? But anyway, does that make sense? Any questions? Yes, sir.
When do you have the grades for assignment 1?
As soon as it's graded. I'm planning on grading it Monday. Technically speaking, people could still be submitting it. So I always wait until all of the submissions are in before I start grading anything. Good. Okie dokie. So, last time we covered what is a class, how do I declare one, how do I give it instance variables, how do I create objects. But, quickly let's review. Classes are declared with the class keyword. Everything inside the curly braces is a member of the class. Instance variables are variables which are inserted at the class level rather than being inside of a method. So, if you declare a variable inside of main, that means that it's local to main. It's not bound to the class. If you declare it here, that variable is bound to the class, not to any particular method. This means that they are available to all methods in the class. Does that make sense? So far, so good? Thumbs up? All right, good. To create an object, we first declare a reference variable of the type of the class. So, all class names in Java are actually data types. All class names are also capitalized by convention. So, I create a variable to contain a reference to an instance of that class. I'm creating a circle variable. I could do that separately from creating the actual object. To create the actual object, new circle. This creates a new object of the class that we specified. Technically, what we're doing is we are calling the constructor, but we're not going to be talking about constructors for a little bit. Okay? Questions? All right. Last time we also discussed how, did we? There's a question. Did we discuss aliasing last time? Maybe this is where we left off. Anybody remember aliasing? No? Okay, all right. Thank you. So, it's important to understand the difference in memory between the object and a reference to the object. So, yeah. Let's say, within memory, I declare a variable, let's call it x, and we say that this is a reference variable to an object of type cat. You remember the cat class from last time, right? So, this thing, type is cat. Sure. We declare this thing with the line of code, cat x. We can then create the object using new cat. X is equal to new cat. This phrase here creates a new cat object in memory. The assignment operation replaces the value of the x variable with a reference to the newly created cat object. So far, so good? But what this means is that x is not the cat itself. It's a reference to the cat. It's just a value in memory. So, what happens if I do this? Cat y. This creates another variable in memory. Type is cat. Right? So, what if I do this? No, not that one. Oh, gross. Y What have I done? What is the value of y? What is the value of y the same as? Yes.
X.
Yes, the value of y is now the same as the value of x, which means it's a reference to the same cat object. Now let's say that our cat had a name property. Let's say that that cat's name was, what's a good name for a cat?
Fred.
Freud?
Fred.
Fred. Okay, Fred is good. We'll do Fred. In this circumstance, if I asked for x dot name, what would I get?
Fred.
If I asked for y dot name, what would I get?
Fred.
Also Fred. If I say, well actually, let me replace that with that. If I reassign the name of x to, oh, I don't know, Garfield, what's the value of y dot name?
Garfield.
It's Garfield, yes. The reason being, x and y are sharing the same memory space. Does this make sense? So this is an effect called aliasing, right? What's an alias?
Code name.
It's a code name, yeah. Or it's like, it's a name that you go by that's not your actual name, right? Kind of similar to the concept of a screen name, actually. Yes?
Sir, I just had a question.
Yeah.
Is the line you put in matter, for example, let's say we said X's name is Fred, and then we said Y is assigned X, but then we decided to change name, and then we did it after Y is assigned X, and we said X is now named Garfield. So would Y still be Fred?
No, it would be Garfield. Because, and I'm so happy you asked that asked that question, because that's the whole point. What we have not done is duplicate the memory, right? We've not created a new copy of the cat. If we had created a new copy of the cat, you'd be right. The name of Y would still be Fred after we changed X to Garfield, right? But because X and Y are sharing the same memory cell,
Because you did Y to X, right?
right, because I duplicated the reference but not the object, right?
Still need to equal the same thing.
Yes, both X and Y here in the program will have the same value, which is the new value, which is Garfield. Does that make sense? And that's kind of the whole point, actually, of what we're doing here. All right? Good. Good. I feel like people are learning. Any questions about that? Any other questions? Okay. So, now let's consider a slightly different program. Similar in theme, but a different thing. Although, actually, do you want me to do that like in IntelliJ to prove to you that it works? You guys want to see it? Yeah. All right. Can everybody please open up IntelliJ then? Man, it's so much better now that it's no longer on Mohawk apps. Love it. Kudos to Karen who got that through. What's today? 2026 dash. So I'm just going to make a new new class, main, there we go. Can you see this at the back? Oh, yeah, well. There we go. It's for my equipment. It really needs to be focused, doesn't it?
Just down there.
Oh, yeah, well, I don't know, that's kind of fuzzy. I don't know, it's. Should file a ticket. So, let's create a simple class. New class, call it class cat. There we go. Very simple. Let's give it a string name. Very, very simple. Cat x is equal to new cat. Cat y is equal to x. X dot name is equal to Fred. S out x dot name. S out y dot name. Execute. We can see that Fred is the name of the cat in both instances. And of course, if I change either of them, reprint both names, you can see no matter whether I'm accessing the object through X or through Y, I'm getting the same result. So far, so good? Okay. Let's consider the following then. Let's say I now have cat A, little cat A, and little cat B. And for cat A and cat B, I declare them as separate and independent objects. Right? Yes.
What should we call classes? One of them I know is cat, but what should we call the first one?
Oh, I just called it main.
Okay.
Yeah, the name, you could call it view, I guess. The name doesn't matter. So, we have cat A and we have cat B. Let's say that A dot name is equal to, oh, I don't know, Mr. Oh man, okay. Peanut. B dot name is equal to Molly. There we go. So, what is the effect of the following? A is assigned to B. Yes?
For Molly?
Yes. If I ask for A dot name, that will now be the same as B dot name. Right? I'm now in the following situation. This is where we were before. We delete this one, reassign it over here. Right? Now, here's a question. What happens to poor Peanut?
Delete.
Deleted, but not immediately. Yes. So, poor Peanut the cat no longer has any valid reference to it. It gets garbage collected. That's right. But the garbage collector only runs when the Java's program decides it's used too much memory and needs to clear some. Right? So it's not deleted immediately. It still hangs out in memory for quite some time, depending on, the execution of the program. However, this is very, very important. It's an important thing to understand about computing in general. If you have data and it's in your RAM and you can't find it, it's lost. It's done. It might as well not even exist, right? You can't just randomly search through the ones and zeros in your RAM chip in order to find like the little bit that was this cat that you lost, right? Not possible. 16 gigabytes of RAM, that's 16 billion numbers, and you're looking for like 3 of them, right? It's the proverbial needle in a haystack. Not to mention, you have nothing to indicate that you found them if indeed you did find them, right? So, if you break a reference, the object is lost. And it's not lost in a nice way, right? This is like, this is like throwing your food on the floor and expecting that mom will come along with the broom and sweep it up for you, right? Not speaking about any children that I have or anything,
How many kids do you have?
I have 3 children. They're all under the age of 5. I have a 4-year-old, I have a 3-year-old, and I have a 1-year-old who's going to be a 2-year-old soon. Well, actually, less soon than the 4-year-old is going to be a 5-year-old. But anyway, birthdays. Ugh. That's why God invented mothers, is to keep track of the birthdays. Yes.
Can I just see the cat.java file again?
Oh yeah, sure. It's very simple. Do you have any questions about it?
Yeah, I'm getting an error.
Ow. Oh, interesting. Try that. Yeah, there you go. Yeah, sometimes public works, sometimes it doesn't. I can't really explain. I don't know why it works in some cases and not in others.
Mysteries of the universe.
Yeah. It's Java though, so I know that must be a good reason, right? Question.
So back on the main.java class, so before we reassign a equals b, if let's say if before that you call the function and you print out a.name, would the name peanut show up or no?
Yes. Let me show you. Showing is better than telling, right? There you go. Here we get Peanut and Molly. Here we get Molly and Molly. Make sense? Yes.
If you don't mind, can you scroll up a bit?
Sure. All right. Good. So, now let's talk about methods. Okay? So, a method is a function. What makes it a method? It's a member of a class. That's what makes a function a method. There's nothing special about methods. There's nothing new or interesting about them if you already know how functions work. They're just functions. But we call them methods because they are in a class. Other languages, like C++, don't call them methods. They call them member functions, which I think is actually kind of more accurate. Of course, in C++, you can have functions and member functions, not just methods. Java only has methods. In Java, everything has to be in a class. So, behold, a function in Python, a function in Java. Note, the def keyword is exchanged for, what's that? Yeah, what category of thing is that? Well, technically, that's a data type, right? So, to declare a method in Java, you must precede that method name with a data type. That data type is the return value, or the type of the return value of that method. No exceptions. Unless it is returning an exception. But that's a different sort of thing. Java joke. Ha 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 ha. Note arguments. What do we notice that's different about the arguments in Java?
You're declaring them all as integers?
We are declaring them all as integers, that's right. We are not only declaring the type of the return value, we are declaring the type of every argument. These are arguments. I don't want to have an argument about it. Those are arguments. So, in Java, the type checker is checking to make sure that you're using methods according to how they've been typed. If you have something that's supposed to be an integer and you give it a double, Java's gonna say, no, you said that was gonna be an integer. You made a promise. You've got to keep your promise. That's what Java says to you. You got to keep your promises in Java. Which is why on the D&D alignment chart of programming language type systems, Java is lawful good. So, there's all kinds of interesting and strange things you can wind up doing in dynamic languages like Python, right? Plus doesn't only mean addition, right? It can also mean concatenation. It does concatenation when it's operating on strings. So, if I put 3 strings in there, what would I get? You'd concatenate them, right? You'd get string A, string B, string C, right? If you put numbers in, you get, 1 plus 2 plus 3 is 6. Does that say concatenation? No. So the method does things that you didn't intend it to in dynamic languages, right? You can fall into traps that way. In Java, you can't abuse the types because you'll get cracked across the knuckles by the type checker if you try, right? So it's easier to write programs that are correct in Java because you're not allowed to do that kind of playing with the type system and, causing anti-patterns and stuff like that, right? Does that make sense? Okay, so Yes. All Java statements except variable declarations must be inside a method, and all methods must be inside a class. When you run a Java class, the main method executes, so we know that already. What's the return type of main? What does void mean? It means nothing. So, the main method is a method that returns nothing. By the way, you can still use the return statement in void methods. You just can't pass it anything to return. Does that make sense? So, good. So, let's consider how we used functions back in Python versus how we will use methods here in Java. All right? The way that you were probably taught to use functions, something like this. If I have a group of programming statements that I want to use several times, I should put them in a function. Right? This is still true. This is still what we're doing. Right? But in object-oriented languages, we consider methods to be actions. That's okay. There we go. We consider methods to be actions operating on the object, right? So when we want the object to do something, we call a method on it, right? So functions, as we've seen them in Python so far, they're kind of, they're kind of loners, right? It's like, I have a procedure I want to encapsulate, so put it in a function. But functions don't work with other functions, they're just functions. Methods exist in collections, right? We have a collection of methods. The methods, like the purpose of a class is to package data with the operations that operate on that data, right? So, the methods of a class are the actions which operate on the instance variables of the class, right? The instance variables are the data held by the class. The methods act on that data. Does that make sense? Any questions? Okay. So, in Python, the arguments we provide are the information necessary to perform the action. The return result is how the results of that action are communicated back, right? With methods, arguments provide new information to the object. Return values take information in the object and pull it back out to whoever owns the object, right? Whoever is able to call the method. So in this, you'll find it's very often the pattern. We're kind of taking these two aspects of a function and we're separating them out, right? Since the data inside of the class is the thing that's key, it's the thing we're trying to operate on, when we pass data in, we may transform it, we may do stuff to it. Most of the time it's going to end up in the instance variables, right? That data is going to get clicked into the class. But that's actually it. A lot of the time, all we're interested in doing is setting values in the object. When we want data out of the object, we request it from the object, but we most of the time don't have to provide any information at that point in time. We can just say, I want that, please. It's like, okay, here you go. Right? So very often, you know, with a function, you'll have like both input arguments that are meaningful and a return value that's meaningful. In Java, the pattern often is a method will have either input arguments or a meaningful return value, but often not both. It'll be doing one or it will be doing the other. Does that make sense? Methods in Java also tend to be smaller and simpler than functions because they're trying to do less. If a thing is trying to do less and the program is shorter, it's easier to debug, right? And that's also part of the reason for object-oriented programming. If you use it correctly, you'll write programs that are easier to work with. Make sense? Thumbs up? All right? Awesome. So, let's write a class. Do I still want to use the cat class? Let me think. Nah, let's write a person class. I don't know, maybe you consider cats to be people. In that case, the cat class would inherit the person class, but we are certainly not that far along yet. We'll put a pin in that for, you know, the better part of a month. So, a person. What are some properties that a person has? Hey?
Here.
Hair, true. Let's give them a name first, though. Let's, string hair, sure. We'll use string to mean color. Maybe int age, right? Yes? Height, sure. Double height. All right. Very good. So far, so good. We need some methods. All right? So, what are some things that can happen with this person that operate on those data?
A birthday.
A birthday, sure. You can modify a person's age. Now, here's a question. You can certainly modify a person's age up. Is it possible to modify a person's age down?
Yes.
If they die, they go back to 0? That's an interesting definition.
Reincarnation.
Yeah, reincarnation, sure. But let's leave all of that. Let's just talk about like standard within a person's lifespan kind of, you know, mathematics. We can write a birthday method. So, the birthday method will act on this data, but it will not return anything, right? Because the effect of the method is on the instance variables. So, void birthday. In fact, we don't need any input to this either. Because when a person has birthday, is it variable how many years their age increases by? It is not. You guys know about the plus plus operator? Did we, okay, it just means plus one. Age is equal to age plus one. That's what that's shorthand for. Okay, all right. I have to tell at least one joke now. Okay. So plus plus means, like x plus plus means x plus equals 1. You guys know what plus equals means, yeah? Yeah. So, there was once a language called C. This was a good language, but people wanted to make the next version of it. So what did they call it? C++. Then, a company called Microsoft wanted to make a better version of C++, but actually they wanted to remake Java. So do you know what they called it? They called it C+++++. That's where that comes from, just in case you were wondering. So, oh man, you know, Microsoft is horrible, awful company. But, you know, they did rip off Java reasonably well, you know, like C# is a reasonably good rip-off of Java, so, you know. It's really not much like C++, though. I don't know why they named it C++++. Man. So. All right, so we have a birthday method. Very good. Let's try using it. Person Q is equal to new person. Q dot age is equal to, oh, I don't know, 10. This person is a child. Q dot birthday. S out Q dot age. I'm probably not going to surprise anybody with this one. But oh look, methods work. Ta-da! Right? So, make sense? Any questions? Okay. So let's consider this class in the course notes. The course notes really like geometric examples, which, fair enough, you know. So let's consider a class representing a circle. To represent a circle in a two-dimensional plane, we need 3 pieces of information. We need x and y coordinates, and we need to know the radius, right? If you're wondering, or if you're curious, what these values do, what the equal signs do here, those are setting initial values for these. You can do that inside of the class as well. Generally speaking, we are doing this here because we do not yet know how to use constructors. We're going to be studying constructors fairly soon. Make sense? Okay. So, there's our data. Get area. This is a method which gets the area of the circle given by these data. Right? Return type is double. As we all know, the formula for the area of a circle is, okay,
E times radius squared.
Pi r squared,
Yeah.
yes. So pi times radius, because I guess they didn't want to invoke the math library twice on the same line. That's how you get pi, by the way. Many, many useful things are included in math. Yes.
Does Java not have a native like squaring function?
It doesn't. Yeah, you want to see what you get instead? You get math.pow. Please note, anything that touches the math library at any point is a double, even if the things that went in are integers. So yeah, actually it's kind of, the math library has kind of an interesting history. This is more or less a direct exposure of the C standard math library. Now, way back, way back, there was a time before these functions were, sort of natively supported by the operating systems. There was a time when if you wanted square root, you would write an approximation algorithm, gosh darn it, all right? And it would be integer, because floats were expensive, right? So you can imagine, way back when you had an 8-bit machine, how expensive would it be to perform floating point operations, given that the smallest floating point number is 32 bits? You can only process 8 bits at a time. How long does it take to process a 32-bit number? A long time, right? So there was a period in time where CPUs would have floating point acceleration circuits kind of stapled onto the side of them. They were, although the chip was kind of natively, 8 or 16 bits, it would have like a 32-bit floating point coprocessor that they slapped on to try to accelerate the floating point operations. It used to be, back in the 90s, that you could measure like a sales metric about how fast a computer was flops, right? This CPU can do 2.3 megaflops. This one can do 4.2 gigaflops. Flop stands for floating point operation per second, right? So like this is a thing that used to be a thing, right? Of course, processor architecture eventually caught up to 64-bit floating point numbers, which is, what's convenient, right? Now that processors are 64-bit architecture, there's really no need for dedicated floating point coprocessors, right? But this math library originates from that time. This was where the kernel stored all of its floating point math operations, right? So it's kind of interesting. It's a bit of a legacy kind of thing. In C programs, you still have to opt in to have the math library available, which is kind of interesting. But C is an ancient language. So yeah, the math library, lots of good stuff in there. It's worth your time to sort of look through it, You've got your trigonometry functions, right? You've got natural exponent, the natural exponent. You've got logarithms. Absolute value comes up quite a bit, But yeah, so that's how you do exponentiation. Here's a quick tip. Python is doing that too. They just mapped it to the double asterisk operator. Just like they mapped all kinds of other things. But yeah. Oh, and there's no such thing as string multiplication in any language but Python that I'm aware of. You know some languages, is that true? Is there any other language with string multiplication that you can think of? Yeah.
Maybe couple for data science.
Yeah.
I'm pretty sure it's GD script.
GD script is Python.
I mean, yeah, but it's slightly different, so.
Yeah. But yeah, given that it's based on Python, that wouldn't surprise me. But yeah, like that's the thing. Like most languages don't have an operator for that because it's not useful. Right? All right. So, but you can see how it would be useful to have a circle that could tell you its area. Right? How about set location? Given an x and a y, and it assigns the x and y to those new x's and new y's to the values in the object, taking the circle, moving it to the specified location. Right? This is a setting method. Draw. That one's a little bit more complicated. It takes as an argument a JavaFX graphics context. You remember GC from assignment 1, right? It takes one of those, executes a few JavaFX methods on it, which draw the circle. So, in assignment 1, you guys probably hard-coded all of those values that you did, right? Wouldn't it be nice to just be able to say, I want a circle with location x, y, and z. Well, x and y, radius z. Go draw yourself. Here's the canvas. And then it just does. Isn't that nice? Isn't that convenient? Right? This one is an interesting conversation about equality. There are some methods in Java which are special. All right? There's a collection of them. Equals is one of those special methods. When you use equality on things, on objects particularly, you don't get what you think you do. All right? Here's a fantastic example. Let me show you how this works. So, just comment this out. There we go. All right. So here, I want to make a third cat. Let's call this cat little cat C. All right? Let's set little cat C, let's set the name to also be Molly. Right? So, we have the B object, name Molly. We have the C object, name Molly. These are still different, distinct objects, but they have the same data in them. Under your intuitive sense of equality, would those be the same? But they contain the same data. Right? Let me ask you a question. Is this cat with this name equal to this cat with this name? Oh, we've got a smart class this offering. as a matter of fact, you're right. They are not equal to each other. Just because objects contain the same data doesn't mean they are equal to each other. So what does make them equal to each other?
If they take up the same space on the memory.
That's right. So here is A equal to B. Yes. So, essentially, your test of equality is a test to see if these two variables are references to the same object. We are equating the value of the reference, which is the memory cell that the object is held at, right? So, what if we want some other definition for that, right? It kind of like, let's imagine that we had like a point in two-dimensional space, right? Just an xy coordinate. It's useful to know if one point is the same as another point, even if they're different objects. Right? Under this definition of equality, they would never be the same. We can write a new definition of equality according to how we think they should be equal. Consider another example. Let's say we had a circle class. Similar to this one. But let's say that right now the circle always prints as black. Maybe we want that to be configurable, right? Maybe we include a new attribute in the class telling us what color the circle is. Fair enough, right? Let's say, for whatever reason, when we're testing two circles to see if they're the same, we are only interested in position and radius. We're not interested in whether or not they're the same color, right? Because we have control over how equality is calculated, we can do that. We can just not compare the colors, right? But compare all the other things. Does that make sense? All right. It makes, so this might seem like an academic point, but it actually, like, this is the root of string comparison, the traditional problem people have with string comparison in Java. So, let's say, just for the sake of interest, I can't use X, string Q is equal to potato. Now, Q is equal to potato. I hope you will agree that if you're coming to this language from any other language, that would be something you'd try, right? Well, did they change it? Did they change Java?
What does it return when you hover over that operator?
What does it return when what?
Yeah, like when you hover over the operator, what does it return?
It wants me to replace it with dot equals, but it's still working. 1 second. I have to, is it the word potato? Avocado. Let's try that. Oh. False. Avocado. Wow. I think they did it. This must be like a thing they did in a recent version. They fixed it.
That's not supposed to work.
That's not supposed to work in Java. I'm not crazy. That's not supposed to work in Java, right? Right? Yeah. Now I have to look things up. Did they fix equals for strings in Java? In Java, strings. Oh, okay. Okay. The reason this works is quite complicated. So there's a thing that Java is doing in the background to try to save memory. Basically, when you do this, strings are always stored statically. Like they're immutable, right? So you can't change string objects. So basically, it's got a great big bucket of strings. When you create a string literal, it like drops that string into the bucket for later reuse. So yeah, actually, these are actually referring to the same object, which is why this is working. But it doesn't work, it shouldn't work if you use like a scanner to do this. So let's see here. Scanner. Input is equal to new scanner. Ah, you learn something new every day, eh? System.in. String q is equal to input.next line. There we go. All right. Let's run that. Avocado. False. Ah, there you go. So because the string that I'm comparing here wasn't defined into like the internal pool of string literals, they are actually different objects, which means you get false, even though it's avocado twice. Java! Java! All right. So what do you do instead? You do the thing it's suggesting you do. You convert to dot equals. Well, objects dot equals. No, you don't have to do that. You just do q dot equals q dot equals avocado. Then you run the program. You enter. Oh, no, there we go. You enter avocado. Ha! Now it's true. Okay. So the dot equals method is for when you want to compare values within objects and not compare things to see if they are the same object. You see why that's like a little beginner trap? Yeah. Any questions about that? Was that clear? Yeah? Okay. So dot equals is one that's like, that's a special method, right? Another special method, one that you're required to use for assignment 2, toString. ToString is the convert this object to a string method. Print this, right? It's the method that by default is looked for whenever you perform implicit string conversion. For example, we have printed a.name. I'm going to just sneak this into the commented section. Boop. We've printed a.name, but what if we just printed a? What would happen? Oof. Yikes. Not pretty. Did they teach you guys hexadecimal? That is hexadecimal, my friends. That's the memory address at which the cat object resides. If you print, in this case, if you print A and B, you'll get the same hexadecimal number. Note that A and B are the same, C is different. If you want to sort of boil this down a little bit, that is what the equality operator is comparing on objects, right there, right? So, that doesn't really tell us anything about the cat, right? Aside from its memory location, which is still information, but perhaps not useful information. Perhaps we want to see something about the cat, right? Perhaps we want to see the cat's name, for example. Within the cat class, if we add a toString method, don't worry about the public for now, just copy it down. toString. Oh, it has to return string. Yeah, there we go. So this is returning a string into which we have spliced the name of the cat. Make sense? So let's see how things change. Where formerly we had memory addresses, we now have actual useful output. Make sense? Very good. Any questions? Okay. Not putting you to sleep, am I?
It's not.
Okay. You guys are just awfully quiet today.
Why is my throat dry? I don't get it.
Or maybe it's just the room. I feel like maybe this room kind of like sucks sound out of the
I'm not
air.
sure. My voice has cracked at least 3 times in this room, so I don't know. Maybe it's something else.
Yeah, maybe it's dryness. Anyway, oh, by the way, in terms of like air and weather, apparently like tomorrow the temperature is supposed to get down to like in the -30s with the wind chill. So bundle up. It's unusual for it to get that cold in this part of the world, but you know, we do occasionally get it. I think someone in the office was saying the last time we had this much snowfall was in the 1950s, which means that this year is an 80-year like snowfall season. Like you'll only see one this extreme every 80 years, which means that this is the most snow most people will see in their lifetime. Just an interesting little factoid.
I like the sound.
Yeah, no, it's quite pretty. Yes.
I heard we're going over like a like global warming tipping point or something like that.
Oh,
We've already crossed like 2 of them. Our oceans can no longer support coral reefs. They will all die within our lifetime.
Always fun.
maybe we can just get like really big aquariums, you know? We have some pretty big aquariums. All right, let's see, where are we here? So, we'll talk about encapsulation, and I think tomorrow we'll take some time to practice some of this stuff. Although you know we are kind of behind schedule, so we got to keep moving. So, encapsulation. What does it mean to encapsulate? What is a capsule?
It is an object where you confine something inside.
Yes, you're trying to contain something, right? Like a little pill capsule, right? You're trying to contain the medicine, right? To encapsulate means to draw a barrier around, right? So, encapsulation is kind of how to explain. So, people are idiots. I include myself when I say that. If you write a program that other people will use, if you write a program that you yourself will use, people kind of have this tendency to kind of like see what they can get away with, you know? People will often, like programmers are the worst for this, all right? If there's some little trick, some little obscure mechanic, some like little, well, technically this works, right? A programmer's going to take that. If it eliminates 2 keystrokes, they'll do it, right? The only way a programmer will do that is if it causes them to write more code than as opposed to less, right? Programmers are all about minimizing keystrokes, and they equate the amount of work they've done to the number of times they've pressed a button on a keyboard, which is actually not true, but that's okay. When you write code, you must write your code defensively. You must do it in the expectation that people will try to abuse your code. All right? So, let's consider our example with the person class, right? We're not doing anything to protect the person's age. We are providing a method that allows us to increase a person's age when a birthday occurs, when the birthday method is called, but we still have full access to the birthday itself, or to the age value, right? So, if a programmer wanted to overwrite someone's age, he could just do it. Perhaps they'd even find that useful. Maybe they don't like your stinky method. Maybe they want to do it their own way, you know? I'm gonna do it my way. And then it's like, oh, well, you see, I wrote that method because when you call a birthday method, it sends a signal to another class that causes confetti to fall from the ceiling, right? I'm not using your birthday method, I'm just gonna add one. I can add one. That's calling a method to add one is stupid. I'm gonna just do it, right? If you've built any safety checks, if it's calling other methods, if it's doing other stuff, all of that is ignored and bypassed because the person thought it was stupid to call a method to increase a value by 1. Right? So how do you prevent it? Encapsulation. Java provides 2 keywords, frequently used, that allow you to set the permission level of everything. At least everything at the class level. These are private and public. Public, we've already seen a few times, right? With main methods, how does that go again? Blank, static, void, main. What's the blank? Public, yes. So main methods are public. Main methods can be accessed by things outside the class. What it means to be private, the thing can only be accessed from within the class. So, if I make an instance variable private, the methods in the same class can access it. Anything outside the class cannot. Declare an object of that type? Oh, you think you can access private stuff? You can't. Not allowed.
Professor, it's the same thing in JavaScript, right? Public and private, no?
JavaScript has public and private? Let's see here.
Maybe she's talking about for CX units.
Oh, maybe. Is that a thing? Well, actually, not very recently, but reasonably recently, JavaScript added syntax, which is very Java-like for declaring classes with static members and private and public members. But traditionally in JavaScript, an object is merely a collection of variables and methods. It's like there was a very long time where JavaScript didn't even have classes, right? Like you don't create objects from classes traditionally in JavaScript. You simply create an empty class and add all of the stuff to it. You create an empty object, you add all the stuff to the object, and boom, that's now the object. You would write like a function to create the object. You would call that a constructor. And that was like the way that JavaScript worked for a long time. This is better, but you know, it's better because it works more like Java does, but you know. So yes, JavaScript does have access modifiers, but you can see they're not doing it the right way, are they? Private is private because it has an octothorpe in front of it. I hate it when they do that. I hate it when Python does that too. Except in Python it's an underscore. Bloody dynamic languages. They should all be blown up. So, alright. Watch what happens when I do this. 13 problems! Yeah. I've locked down the name of the cat. You can no longer write to it. You can no longer read from it outside of the cat class. You can see there are 13 places where we're doing is exactly that. And oh look, isn't this handy? Isn't this handy, IntelliJ? You can click 13 related problems and it gives you a list of all of the problems. Ooh, I wonder if that's useful for debugging. So, okay, all right. How do we get, like, this is obviously too much restriction. How do we work with the name of the cat? Right? You write methods. Right? So, we must ask ourselves a question. Do we already have one that tells us the name of the cat? We do. But sometimes it's valuable to just grab the value itself, right? So, we write two methods, a getter and a setter. All right? So, public get name, public string get name, does not require any arguments. Return name. Okay. We can now read the name. This seems very simple though. Why would we do this? Why would we have a method which only returns a value? Because cats and kittens, if you want to put more code there, you can. Maybe, if the name of the cat is a secret, it doesn't tell you. If name dot equals secret, return you're not allowed to know. Otherwise return name, right? We can do that. We can put code in the way of people reading the variable directly. We can add safety conditions. All kinds of stuff. Let's see. Is it ever the case that we shouldn't allow the user to write the full range of something into a variable, you know? Ooh, did we do an assignment recently where the user could enter a number and that number could put a paddle off the screen? Yes. Public void set name. If, you have to take an argument though. String new name. If new name is equal to, see what I almost did? Dot equals, there you go. If new name dot equals Garfield, then do not set name for copyright reasons. Else, name is equal to new name. By the way, in IntelliJ, if your identifier is highlighted in purple, that means it's an instance variable of the class. arguments and local variables are in black. Okay? It's sometimes a little tricky to sort out what belongs where. We'll get to it. Does that make sense? So, all right. Now, we need to go through, unfortunately, oh yes, sorry, question.
I saw that you just put comments in the thing where you don't want to do anything. Is there not something in Java to say do nothing, or do you have to put comments?
Oh, that's an interesting question. I don't know if Java has a skip. I mean, really, I should be doing like that. Right? It's just kind of a weird construction. That's better, right? Does Java have a skip? Python has a skip. Pass, yeah. Yeah, I don't believe so, but I believe in Java, like, empty curly braces is legally valid, so you can use that, like, that's your skip. That's your pass. Whereas, pass is required in Python because anytime you have anything with colon indentation, there has to be something on the next line. Like it's syntactically required in Python to have something on the next line. So even if it's empty, you need to put like the pass statement in there in order for it to compile, right? Yeah. So now the thing that you have to do is you have to go through each instance. Instead of name is equal to Fred, we set name to Fred. Right? Instead of reading the name, we get name. It's a little bit of a pain. But, you know, this is the life you chose, so get used to this sort of thing. And if you do this from the beginning, then you don't have to go all the way back through your code and fix it like this. But of course, I'm teaching. I have to teach. So I have to do stupid things and then show you how to fix them. Because it's boring if otherwise, actually. All right, invalid, invalid, invalid. Okay, should we compile it? Let's see if it works. And there you go. Everything works. Everything is encapsulated, and if you'll notice, the term Garfield was not set for copyright reasons. Make sense? Any questions? Okay. Let me just see if there's anything in the notes to mention. Yes. We did talk about toString. Yep. That's a talk for tomorrow. So, here's just a taster. This is what a UML class diagram looks like. The thing we will be opening with tomorrow morning, assuming there's no, snow day, meteorite strike, sickness, invasion by the Americans, or imminent apocalypse of any zombie apocalypse, right? We will start off with how to create class diagrams because, you're going to have to do it for your assignment. Sounds good? Any questions? All right, well, thank you very much for your time and attention, folks. We will resume tomorrow at 9.
Officer?
Okay, hi everyone. If you haven't met me yet, my name is Jackie, and I'm the PAS leader for this Java course. And so we have sessions after each class every single week. I'm also going to email you sometimes to remind you. And so there's a session today, and it's right after this class from 12 to 1 in room E033. So it's the room beside the room you guys were in yesterday. And what we're going to go over is model and view coding, like practice questions that are going to help you with your assignment, and also test 1 practice questions. I have a very photogenic memory of what the very first Java test was like, so this is based also just on the course content that you covered up till now, and so I have some practice questions to go over, because the more you practice, the better you'll likely perform on the first test, and so it'll be a real confidence boost if you do well. So yeah, that's what we're covering today, and so hope to see you guys there.
Thank you very much. Yeah, if you guys are looking for some practice that you can do, one thing which I highly recommend everybody do in this, like whenever you're picking up a new programming language, and you should have enough now to be able to do this, go back to a previous programming course that you've done. In this case, it'd be Intro Python. Take your old assignment questions or practice questions from that class and just re-implement them in this language, in Java. That's a great way to highlight some of the distinctions between Java and Python, while still getting some practice in a way that kind of like, oh yeah, I already know how this program works. Let me see how this works in Java. It's a good tip. But yeah, test 1 will be Friday, February 13th. So mark it on your calendars. Is that too dark? Maybe a little?
It's good.
Good. Okay. Well, here we go. So, following on from yesterday's conversation, we had just talked about encapsulation. So, we now know enough about the structure of a class to begin discussing UML diagrams. UML, the Universal Modeling Language, as I joked yesterday, is neither universal nor a language, though it does model things. How do I know it's not universal? Because there are at least 10 variants of UML for different applications, which means that not one of them is universal. It's a kind of a silly thing to claim, actually, that anything is universal, since we only have access to the known parts of the universe. So, there is a link you'll find in Canvas under Student Resources, draw.io for UML diagrams. we are going to be using draw.io as a piece of software to assist us in the drawing of UML diagrams. So let's follow that link. There is both a version that you can install locally, and there's a sort of online browser-based version, which is what loads here. Looking good? Looking good. So, this is a follow-along segment, so if everybody could please follow along. That one again. If you go to the modules on Canvas, student resources, draw.io for UML diagrams, there you have it. Put your thumbs up. Put your thumb up when you got that. Alright. So, you'll notice there are various different symbol palettes along the side which you can use. UML is the one that we're interested in for today. UML, there we go. You'll notice that we have a wide selection of different things, including a stick figure. But we're not so interested in the stick figure. We're interested in the third option here, class name, field, and method. A class diagram. So, to add this to your UML diagram, you simply drag and drop from the palette. You can see we now have a class name. Sound good? Okay, so in general, the bar at the top is for the name of the class, although you could probably figure that out yourselves. All of your attributes or instance variables are put in the next bar, and all of your methods are put in the third. So, let's take one of the classes from the notes and create a UML diagram from it for practice. How do I get that?
Oh.
Now that'll do. Yes.
So, do you ever click on the top left icon?
Ah, there we go.
Or that?
Ah, merci beaucoup. There we go. That's a little nicer. The people who are watching at home will thank you for that. It's kind of funny. It's like, this class was filmed in front of a live studio audience. Let's see here. This is a good one to start with. Let's take a look here. We have a class, rectangle, 3 attributes, and 2 methods. Now, we're about to do the thing I said not to do. We're about to take Java code and encode it as the UML diagram. Technically speaking, you're supposed to do the diagram first and then write the Java code, but we're still learning how these diagrams work, so that's how we'll go for now. Just keep in mind, this is a design, and you're supposed to do the design before you do the implementation. Okay? Yeah. So, To fill the thing out, it's very simple. Double click. This will be class rectangle. Now, one of the things that you'll need to get used to about UML diagrams is that all of the symbols are important. All right? This little plus sign here means public. Anybody care to guess what the symbol for private would be then?
Negative sign?
Negative sign, that's right. So, if we swap that out for a negative sign, you'll see all three of our fields here are private fields, so that's what we want to go with, right? We then list them all, field name, colon, type. So, width, colon, integer. Uh-oh. Pressing enter hasn't really had the desired effect now, has it? In order to add additional fields and methods, you have to drag them in from the palette instead of pressing enter. That would be too intuitive, right? So, if you hover over the fifth item in the palette, item attribute, that goes there. When you need more of them, that's where you get them from. Don't use the emoji one. You'll use that for both properties, instance variables, and for methods. So if we drag and drop, there we go. We can even do a couple of them. You can reorder them. Everything is good. So, height is an integer as well. Area is an integer as well. So here's an interesting question, right? Just about this class. Let's use our noodles for a moment. So we have a rectangle, and we want to have that rectangle, we want it to be able to give us its own area. Sure, fine. Do we need an instance variable to store it?
Not really.
No.
Yeah.
Why?
I think we just put another formula for that and use it for every single time
Precisely so.
Yeah.
If we have a method that's calculating the area, we can simply calculate width times height from that,
Yeah.
right? We don't necessarily need to store the value as data, right? So everything in software design is a trade-off, right? There are advantages and disadvantages to both approaches, right? If you're calculating your area on the fly, right, that means that this method is going to take slightly longer to execute, right? Every time. However, if you're storing the data, right, you still have to calculate it, but you would be calculating it when you set the width or the height or both, right? Anytime the dimensions change, you have to update the area, right? So, also it costs a little bit of memory to store it, right? So, it all comes down to profiling. You need to know how frequently you're setting versus getting that data, right? If you're setting the data this many times, getting the data that many times, right? It makes sense to calculate it down here, right? Because that's going to be run a lot less. If it looks like this though, you set the data twice for every 100 times you read it, it makes more sense, and like ratios like that do exist, right?
Yeah.
They can be even more extreme than that. If you're setting the data not very frequently, it makes sense to load that data, load that computation there rather than in the other one. That's like, when you talk about optimization, that's the type of thing that you're talking about, right? People sometimes kind of have this, have this question, like intermediate programmers kind of have this question. It's like, okay, so I kind of get the basics now, all right? I understand how programs work. I've heard that optimization is important, but it's like, it's not obvious to me what makes code optimized, right? That's one of the things, right? There's a term for this, right? Storing data from calculations so that it can be read easier later. There's a term for that. Does anybody know the term? The term is caching. C-A-C-H-E, cache, right? So, back before the price of memory blew up, we used to say things like, if you can spend a little money to spend a little memory and money are basically the same thing now. If you can spend a little memory to gain a little runtime, you take that exchange every time because memory is so cheap, right? Now, that didn't used to be the case back in the 80s and the 90s, right? It certainly was the case, up till very recently. And, realistically speaking, we still have exorbitant quantities of memory available very cheaply relative to like the 70s, right? Even though the price of memory is exorbitant, like the price of memory chips is exorbitant, we're still in a phase where you take that deal every time, right? But yeah, maybe we won't be in a few years, we'll see. A very strange thing has happened in the last year in the computing industry. Like a very strange thing. For the entire history of computation, for as long as there have been computers, the price per unit compute has gone down with time. That's been true since computers were originally developed, right? Now, somehow, for some strange reason, the price of computation, the price per unit of compute, the price per statement you execute has gone up. It's bizarre. Nobody expected this. It's like, if this isn't a blip and the pattern holds, languages like Python are going to be in trouble, right? Like, if we're entering a phase where the price of performing calculations is going to be increasing for a period of time, a period of some years, basically that means that programming languages that waste computation are going to become less popular in favor of languages that don't waste it. Yeah?
Yeah, that kind of reminds me, a long time ago, Mohawk used to teach C
Yeah.
and stuff, and so now we don't teach any low-level programming languages here, but I'm wondering if that would cause that trend shift, right? To then suddenly go to bare metal programming and
Yeah.
stuff like that.
I mean, you don't have to go all the way down to C, right? All you have to do is get away from all these interpreted languages, Like, even Java is like, it's pretty fat, in terms of its memory footprint. I've heard that okay, so what this really is, this is like the setup for Rust to take supremacy, basically. And, it's interesting, right? Because if you look at a Rust program, it's actually got a fairly big footprint. Like, Hello World in Rust is something like 50 megabytes, which is a lot for a Hello World. Like, that's comparable to like Java or something like that. But the thing it's doing is it's statically linking all of its libraries, right? So in C, the reason that hello world is so small is because it's like, yeah, okay, here's the string hello world, pass that to the kernel function, I'm done, right? What Rust is doing is it's saying, I don't trust you, kernel. I'm going to take your print procedure, I'm going to embed that in my program, and I'm going to just run it myself. So Rust is still efficient, even if the sort of footprint, the memory footprint is reasonably high, even for a basic program. But yeah, anyway, yes, what was I talking about? UML diagrams. So that's pretty much all she wrote in terms of properties. That should be fairly easy. Now, with methods, we have two methods here. We have getArea and setDimension. So we provide the method name, setDimension. We'll probably have to give it some room to expand. setDimension takes integer width and integer height, and it is a void function. So, within the parentheses, we provide the types of the arguments. Int. That's put us over the line, so let's just, no error, please. Please no, come on. Oh man, there's the stupid thing, there we go, all right. So, it's somewhat unfortunate, but even within the course notes, there are inconsistencies about how you lay out a method in a UML diagram. For example, when the return type is void, often the return type is actually just excluded. You'll see this occasionally, right? That's okay. On an assignment or test, I will accept either of these. All right? Missing return type means void. That's fine. Another variant that you'll see the actual name of the names of the arguments provided in the class. Oh, no, come on. There. Again, you'll see it occasionally in the notes where it does it this way. That's probably better for documentation, right? But if you're kind of looking at it from the perspective of a type purist, that's unnecessary information, therefore should not be in this design document. But again, I will accept either one of these. I'm not going to be fussy about that. I will be fussy about plus versus minus, because that's important, right? I will be fussy about the thing being divided into distinct areas. I will be fussy about everything in your design being in the code has to match the design. in the end, right? But in general, any one of these notations I'm fine with respect to the methods. Sound good? Fair enough? Good. So let's do the final one, get area. Also a public method, get area. It takes no arguments and returns an integer. There you go. So one thing I would like to point out, notice that the colon is a type of operator here, right? In Java, especially when this is most sort of evident when we're doing arguments, although it's also true up here. When we type something in Java, we say type name, right? Type space name. Here, we say name colon type. This is closer to how the formal mathematics is expressed, but you'll get used to it. Sound good? Any questions? All right, so when you do your assignment 2, you will need to construct a UML diagram with 2 classes. Are we doing the view? I think it just says to do the model, but
Yeah, I was gonna ask, how would we even be able to transport it to IntelliJ?
transport what to IntelliJ?
The chart.
You don't. You do this. You like export a PNG. You submit that. Then with your eyes and your keyboard, you look at your design, and that's how you code it.
So what, we just copy and paste that into our code?
No, you just write your code, and this is like side documentation.
Oh, okay, so
Yeah.
it's just a separate thing from it.
Yes.
Got
You're not like, I'm sure there are certain things floating around right now that might attempt to take something like that and generate code from it. In fact, it's been the dream of people into meta-modeling to be able to take UML diagrams and just generate the code from that without having to actually write the code, but that's been a pipe dream for many, many decades. Question?
Will we have to make UML diagrams for our tests?
Yeah, that's testable. UML diagrams will be on the test. You will be expected to read them and write code based on them and a description of what the methods do, right? You will also be expected, for example, given some code, do the process we just did. Make sense? Yeah, so it's like, this is proper testable material. Any questions? Okie dokie. So, I kind of already set this up as I was talking about the way that area, like when area gets calculated. But, you'll find this is a thing with me is like I'll kind of like run ahead of the slides a little bit just because I'm so excited. So, because you folks are interested in software, presumably that's why you're here, you may have heard the term API, right? Can anybody tell me what they know by the term API? Like, what does that mean to you? Because it means many things.
From what I've heard from it, I usually hear from like modeling in like Minecraft stuff like that.
Sure.
It helps with libraries with certain mods to more like kind of like what's the word? Kind of be like a break, I guess, in a way.
Yeah, that's a good way to think about it, yeah. Anybody else? What's an API? Oh, at the back?
I've heard it used in the context of like modding apps on phones.
Okay.
Yeah.
Modding apps on phones, yeah. That's probably like reasonably similar, you know, although they are different programs, similar in concept to modding Minecraft, right? Yes?
So, it's, I'm hoping I'm pronouncing it right, hurt?
Hurt?
Yeah, is that the, like, what they mentioned earlier? I'm hoping I'm saying it right. Is it hurt or is it pronounced something else?
I don't know what that is actually.
No, like what you guys were talking about. With
The modding?
Yeah, the modding stuff.
Oh. I don't know. REST is an acronym that's often used next to API, REST API, right? How many people have heard of a REST API?
No.
Wow, really?
But what was the other API you mentioned then?
I was.
That's
I guess
something
it's a
else.
server side thing.
I mean, yeah, but you know, lots of people in web kind of talk about REST APIs, you know. Yeah, it's kind of like how plugged in is this group to like the internet kind of development culture, right? Yeah. So API. Who can tell me what it stands for? Yes, sir.
Application programming interface.
Application Programming Interface. Okay, so that's actually a very general term, right? Basically, any time a program presents an interface that's not a graphical interface, but a programming interface, that's an API, right? Now, the term API has different, like, it means different things in different contexts. One of the fun things about the field that you are currently entering is different areas of the field will use the same term to mean different things, right? So you have to be on top of the vocab. Fortunately, all of you elected to come to school to learn this stuff, so you'll get hopefully something towards a formal education. So, the most common use of the word API at the moment is a web API. This is something we're going to learn how to do once we get to server-side programming. We'll learn how to put together a web API. All that really means is that someone is able to fire HTTP packets at a server, and the server treats that like it's calling functions, right? They're calling functions rather than issuing pages. Those functions very often are hooked up to databases in the back end. In Java, however, when we say application programming interface, we are talking about the interface of a class. The interface of a class is the collection of all of its public things, plus its documentation. Right? So, if you remember when yesterday when we were talking about private versus public, when we lock something down as being private, it means that the thing we locked down cannot be accessed outside of the class. It's internal. So, the correct way to think about public things this is my intended interface to users. Please use this class this way, right? Which means your default stance on things is that they should be private, right? There's a very important principle in programming, like security and just general like maintainability. It's called the principle of least privilege. Principle of least privilege. The principle of least privilege states you should give people no more access than they require to perform the function. Right? This means your default stance on things inside classes should be private, not public. Does that make sense? So, a good example of principle of least privilege, let's talk about CS Unix, right? All of you on CS Unix have accounts, right? Your login gives you access to your account directory. It does not give you access to everybody else's account directory, right? Why? Because you could very easily go in and commit the academic integrity violation by stealing other people's assignments, right? You, like, even if you're a good person who would never do that sort of thing, and I know every single person in this room is a good person who would never do that sort of thing, you still don't want to leave the door open for it, right? Because you have to assume that people could be bad actors, right? On CS Unix, my account has an elevated level of privileges over your account, right? I can view the content of your account. I don't need to know your password to go in and look at your assignment submission, right? My password works on your account, right? That's how I grade your assignments. Now, because I'm a professor, that's necessary for my role, right? It'd be a huge pain in the keister if I didn't have that level of permission, right? But, do you think that my access, even my access, to CS Unix is absolute? Do I have access to everything?
No.
I certainly do not, unfortunately. I do not have super user privileges on CS Unix. So super user is like, it's analogous to admin on Windows. What that means is I cannot install programs for all users, right? I can't create accounts. I can't modify permission levels of accounts. Like I couldn't pick a student and promote them to professor. I can't do that, right? So who does have those permissions? The IT department does, actually. The IT department has super user permissions on CS Unix, which is why, up to a certain point, I can help you do stuff on CS Unix, right? I can reset passwords for you, but only because they made a script available to us to be able to do that. Our accounts don't natively have that ability, right? But like, if your account is like screwed up beyond a certain point, I will just have to say, you need to go talk to IT about that, get an account reset or something like that. Like, there's a point at which my ability to fix your problem ends, and that is like where the permissions in my account end, right? So, principle of least privilege. Principle of least privilege is protecting you in case, there's a rogue student or a rogue professor, someone tries to use something that they shouldn't do, right? You think about that beforehand and you lock things down so that it can't happen. Principle of least privilege. Make sense? Very good. So, that's what you should be thinking about when you're creating the set of public things in a class. What interface am I providing to the user? Don't provide an interface to things the user shouldn't be able to modify. Right? What are things a user shouldn't be able to modify? Well, let's return to one of our examples from yesterday. The person class. We had a person with a name and an age, right? We shouldn't be able to modify a person's age, right? That's at best, we had a birthday method that could increase a person's age by 1, right? But we should not be given access to set a person to age to anything we like, right? Because that's not an accurate modeling of how age works, right? So, if you make a person's age public, like the instance variable, you're giving the user exactly that ability, the ability to make that age anything they want, right? And you shouldn't. Okay. So, that is interface. Implementation. All of the private things in the class, including the bodies of all of the methods. You guys know what I mean when I say the body of a method? So, similar to an HTML document, where you've got head and body, yeah?
It's the inside of a method, right?
It's the inside of the method. All of the statements inside the curly braces, that's the body. Yeah. Yeah, very good. Comments inside methods apply to the implementation. So comments inside of methods are intended for the people developing the program. The comments, the JavaDoc comments, the comments on the interface, apply to both the developers and the people using the class. Right? Good. An important detail when you're designing classes. A person who is only using your software, not developing your software, should not need to know any of the information in the implementation to use your software. They should be able to use the interface only, not have to look at the source code. Right? Which means, when you're documenting a method, you need to clearly explain what is expected for these inputs, what am I expecting to input. This includes what is the acceptable range of inputs, right? What is the output of the method? We need to say what the method is, what the method produces, and if that doesn't explain the method clearly enough, everything you need to know about what the method does should be in its documentation above that. Does this make sense? Okay. It takes a little getting used to. But yeah, so. Imagine how much more difficult would it be if, in order to use system.out.println, you had to actually know what system.out.println was doing, right? How it was moving memory around. Printing would become a much more difficult task. Much easier to just pass it a string. Here's your string print line. Print line's like, okay, I'm gonna print that line, and then it does, and you're like, oh, it works, yay! Yeah. Right? Look at me, I'm a programmer. I've done Hello World. You know? Sure. If it was, you know, like basically the entire software ecosystem depends on this principle, right? You folks will probably go your entire careers without having to worry about assembly code, right? And that's probably a good thing. Assembly code is difficult and small and tedious, and you can't get much work done in a workday, you know, working in assembly. You guys know what assembly code is, right?
No, which is what I was.
Oh. Okay, so, you know the CPU? The CPU has an instruction set. Each instruction in the CPU is a little area of circuit that performs a calculation. Assembly code is a programming language that compiles directly to machine code. Machine code is the set of instructions of the CPU. So, let me show you a little bit of what assembly looks like. This is like what a normal assembly code program looks like, right? Every line is like one instruction for the actual CPU. These are CPU instructions directly, right? This compiles one-to-one to machine code. Basically, it just replaces things like move and, you know, compare with the actual machine opcodes, which are numbers, and that's all it's doing in terms of compilation, right? All programming languages compile to that, right? This is difficult to work with. It's a language in which there are no loops, there are no if statements, there are no variables. All you get is instructions and registers. You guys can get through your entire programming careers without even knowing what a register is, right? And that's probably fine. Why is it that we don't need to know assembly code to write Java? It's because we have been provided a series of constructs that behave well, that we can know the behavior of without knowing how it's implemented here. Now, you know, because I'm a bit of a classicist, I always believe that a greater understanding of the underlying thing can improve your ability to program the overlying thing, right? It's kind of like, you know, you can be a good programmer without knowing assembly code, but to be a truly great programmer, you know, you probably need some knowledge of assembly code, right? And it is my hope that all of you aspire to be truly great programmers, right? But, you know, for your kind of like workaday web development job, this is like the last thing that's on your agenda for the day. You know, like you don't need to know assembly to do that, because you've been given an interface to it that works, right? That you can understand, that you don't have to dig into this stuff to get work done. Make sense? So that's kind of what you're trying to do. Every time you load up a new JavaScript library, a new JavaScript framework, right? You're basically being given an interface of pre-built things that you just have to know how the pre-built thing works. You don't have to know how the whole system works, right? Making sense? Very good, very good. Okay. So, another very important consequence of separating the implementation from the interface is that we can change the implementation, leave the interface alone, and it doesn't break people's code. Right? This is very important. If you want to make people mad, break your API. That makes people mad. Alright? Like, do you guys know what the term deprecated means?
Mm-hmm.
What does deprecated mean?
Doesn't mean to like keep something away, or takes like keep something
Like
away or
it's-
take it away.
Take something away? Yeah?
Want something in worse condition?
Sort of, yes.
Would be something that is obsolete.
Sorry, can you say that again?
Would be something that is obsolete, for example. in-
Obsolete, yes, something that is going to become obsolete or is already
Yeah.
obsolete. Marked for deprecation. So, like if you want like an English definition of the word deprecate, it actually kind of means like, you know, I'm not saying that your work is substandard, but if I was like if we were at a meeting and I like raked you over the coals for your work being substandard, I would be deprecating you, right? That's the definition of the word deprecate. But in software programming, what we mean by deprecate is this is going to be removed in future versions, right? Do not use this anymore. You should be switching to the new version of whatever this is. Yes?
So kind of like what Apple does within software.
Yeah. Well, it's a little different, right? Because like that's kind of like planned obsolescence, right? Deprecation, like it's more like this method is a mess. It's got all kinds of security flaws, and we can't fix it. We had to write a new one. Please switch to using the new one because we're going to get rid of the old one. That's, you know. But when you deprecate something, like you mark something for deprecation in a future version, and then you have to give people years to switch over to the new version before you finally say, okay, that's it. This thing's been on the deprecation list for 3 years. We're getting rid of it. And then you still have to listen to the complaining, right? It's very, very hard to remove things from a language. It's very, very hard to change the interface. This is like one of the fundamental laws of computing. This is why new languages come into existence all the time. Why new JavaScript frameworks come into existence all the time. The C programming language has been pretty much the same since 1968, right? The reason that the C programming language has not changed appreciably since 1968 is that people took that language, they wrote kernels for operating systems with it, and if ever they took the C programming language and they changed it in such a way that old programs don't compile on it anymore, nobody's computer would work the next morning. And I'm not even being facetious. That's like actually true, right? If like anytime any C program was recompiled, if the source code didn't recompile, the computer would break. And that's the kernel of all computers is written in C. So you would literally break all computers if you changed C, right? So we try not to change the interface. It's like, okay, sure, so we're going to try not to change the interface. But obviously we still need the ability to update like methods and stuff, like security vulnerabilities have to be patched. How do we do that? You can change things under the hood, right? In Java, you can change things inside of the method, so long as you don't change the interface. What does it take in? What does it put out? These are changes which are allowable. Think back to our rectangle example, right? From the perspective of the user of this class, here's rectangle class A. Area is being stored in the class. Here's rectangle class B. Area is being calculated on the fly when requested, not being stored in the class. The user, most users, wouldn't even be able to tell the difference. Right? In order to tell the difference between these two classes, you would need profiling software to see how much memory they were using, or be able to take very minute measurements about how long the methods were taking to execute. Right? Which is possible. Like, that's a job you can get actually, right? Profiling software is like that's a job, right? But that's not most users, right? Most users are just using the software, right? Make sense? Good. All right. That's I think that's topic 3. Yay! Okay. You want a very slight anecdote? I'll keep it quick about profiling and how that led to a fairly major the discovery of a fairly major exploit before it became a problem. And this happened last year. This is a fun story. Okay, so in Linux, there's a program called SSH, Secure Shell. It's actually the same program that lays behind PuTTY. PuTTY is just a Windows interface for SSH, right? There's a piece of software, a compression library, used by SSH. It's a project on GitHub, and one guy maintains it. Just one person. In his spare time. Okay. It's actually not good to have a really, really important library like that maintained by only one person, because what if that person was hit by a bus? Right? That compression library, someone has to now pick that library up, right? Try to figure out what to do with it, because it's important for the software to be maintained. It's not like the guy wasn't doing anything for the last 25 years, right? People age, people get old and die, right? That guy was getting old and was looking for a successor, right? But oh my goodness, someone wants to help me on the project. They've started making pull requests. Ooh, and the code isn't too bad either. Over the course of the next 2 years, this other user on GitHub basically builds up his reputation with the guy who has all the permissions to the point where he's finally made like a co-collaborator on the project. He's the future inheritor of the project, right? Okay, good. Cuts to the Debian cut to a guy who's profiling Debian, right? You've heard this one, eh? Yeah. So there's this guy, and he's like, he does security work on Debian. Debian is like one of the base Linux distributions that many other families are derived from, right? Ubuntu is ultimately based on Debian. Mint is based on Ubuntu, which is based on Debian. Like if I went through like the top 20 distros on DistroWatch, probably 60% of them at least are Debian derivative. So he's going through and he's doing stuff and he's like, did SSH just take like 0.2 seconds longer than it's supposed to? I'm gonna profile that. I'm not imagining it. Yeah, that thing took longer than it's supposed to. I wonder why. Digs into the code a little bit further. Oh, you're doing stuff you're not supposed to be doing. So, this is what had happened. All right? This compression library had built into it an arbitrary code execution exploit, which means basically the compression library could be used to run code on a remote machine. It's a backdoor, right? A backdoor had been built into the main utility that everybody uses to have two computers communicate with each other, right? To say that this is a serious exploit is to say almost nothing, right? It would have given this guy access to every computer on the internet, right? And it was all found because this one Debian security guy was like, that took like 0.2 seconds longer than it was supposed to. Profiling is important. So, and it's interesting, right? The way that this worked, the way this happened was quite clever. Because this, you'd say, well, but this is supposed to be open source software. How is it that this wasn't noticed, right? Code review is a part of that process. Wow. The guy had collaborator privileges. The code that was in the repository was not the code that the pre-compiled binaries had been compiled from. Right? So, yeah?
I just want to say it wasn't 0.2 seconds, it was 0.002 seconds.
Oh, I'm sorry, 0.002 seconds. Good grief.
I thought it was 0.02 seconds, it was more accurate than a lot.
Oh, man. Kudos to that guy.
It was the difference between 1005 and 1007 milliseconds.
Kudos to that guy.
Yeah, that was crazy.
Yeah. So, where was I? Yeah, so he built the exploit into the pre-compiled binaries, but he kept it out of the source code everybody was looking at, because who checks to make sure that the source code in the repository was the thing that the pre-compiled binary was compiled from, right? So, he's been found out, this guy. So guess what? He had been, or she, had been, or they, had been anonymous this whole time, right? Never had a real name been used. Never was this person ever like actually, you know, known for who they are. So what happened? They do, you know the Homer Simpson disappearing into the hedge meme? Right? That's what happens with this guy. Disappears.
Just like,
Never heard from again. Yeah.
like this.
Yep, just like that. Or just kind of slowly sinking into the chair, right? So, no consequences. Okay, so there are various theories about this. One theory is that this might have been an intelligence agency, right? Because if you were a spy, right, access to any SSH communication on the entire planet, that's pretty good. That's a pretty good, like, if you're an intelligence agency, that's a pretty good in, right? And like, you know, you have to keep in mind that like the internet was built by like DARPA to begin with, right? So, you know, yeah, pretty bad.
But then, like, what does that say though? If like future people just know to keep the performance the same, right? If they can do equal benchmarking and that sort of testing, then it can be easy to kind of insert other exploits as long as nobody notices a change. Like I feel like there's always creative ways around it.
Yeah, no, we were very lucky. We were very lucky because this particular code exploit caused the 0.002 millisecond increase in time. And if it hadn't, you know, one might say if the mysterious attacker had been a little better at their job, right? You know, that would have gone through. Nobody would have noticed. Right? Kind of makes you wonder how many other kind of little projects like that have been gotten through. You know? That's just one that we know about. So, don't trust the internet. Don't trust anything that's on the internet. The internet is not your friend. Computers are not your friends. Never trust a computer that you can't throw out a window. You can trust your pocket calculator.
Hooray.
Yeah.
And that's about it.
Good. Well, we're kind of between topics, so I'd like to get on to the week 4 material today, as we are, you know, we're still behind. So, but since we're between topics, I think that this would be a good point at which to take our union mandated break. It's not actually union mandated, but you know. Question?
How can you make it public?
Oh! Principle of least privilege. Yeah, okay.
Thank you.
There you go. Oh, I'll make the solutions available as well from last week. Okay, so if you didn't get the flavor of this course so far, any exercises from the exercise documents in the modules, if we don't do those in class, those are your homework. Those are your practice. Okay? Right. Good. All right. Sounds good. Let's have our 15-minute break then. Math. Please be ready to resume class at 10:24 a.m. Thank you very much. Get that guy up and running, please. So, just make yourself a new project. There we go. Let's make ourselves a nice little Java class. Let's call it person. Can you see this in the back corners?
Yes.
Good. So let's create a class with a couple of properties. Let's say private age, private name. Age will be an integer, name will be a string. So, let's write ourselves a couple of methods to access these values. Public int get age, return age. Public string get name, return name. Very good. So far, so good. We run into a practical problem, however. While it's true that we should not provide the user any direct way to, just set the age to whatever they want. Ooh, we need to put the birthday method in here. Public void birthday age plus plus. There we go. While we need to, this is all good, right? We should be able to read the name and the age of the person. We should not be able to set the person's name or set the person's age. What are our initial values?
No.
Null in the case of string, because strings are objects, and null is the default value for an object. What's the default value for an integer?
0.
0 is correct. So we could pick some default values here. There you go. Default name. But this also has its problems, right? The class as written will only ever have a name of John Smith and an age of 10, perhaps more, given that we can increase it, right? We might as well be setting a constant, right? So, while we do not want to be able to set the age to whatever we want in general, it is useful to be able to set some properties of a class, of an object, pardon me, when that object is created. And then not set those, not give ourselves the ability to set them at any point past creation. We want to be able to configure the default, the initializing values, right? Well, one way we could solve this is we could write public void set age int new age is equal to new age, right? That's one way we can do that, but if we do it this way, we are trusting the user to not call that method after the initial creation. Do we ever trust the user? No, not so far as we can help it. Java provides us an alternative mechanism. Enter the constructor method. It's a special method. It's only ever called once when the object is created. Well, it's called once for every object, right? But within the scope of one object, the constructor only runs once. Its purpose is to set the initial values in memory. It can take arguments. This is how you write one. Constructors are usually public. The name of the constructor is the same as the name of the class. You'll notice it's not complaining that I forgot the return type. The return type of the constructor is a reference to the newly created object. So really, this is both the name of the method and the return type. If we were to say the return type explicitly, it would be public person person. And that's, I guess, a little too verbose even for Java. Right? Do you understand what I'm saying there? Let me show you. So, might even accept that. Public person person, right? Person, the name of the method needs to be person, otherwise it's not a constructor. The return type of the constructor is a reference to a person object, the newly created one. But those are the same thing. So in Java, we only need one of them. Make sense? Okay, so this is where we set the initial values. We preferred to do that over assigning them here, as a matter of fact. So, the constructor can take arguments. So, it kind of makes sense. If you create a new person object, that person's age starts at 0, right? So, within the constructor, we are assigning 0 to the value of the age instance variable. This, however, is a little trickier. This is a common construction in Java, but it's not quite syntactically correct. Do you remember me saying previously that if in IntelliJ the identifier is purple, that means it's an instance variable of the class. If it's gray or black, it's an argument. Notice how this isn't purple? We've run into scoping issues. So, you guys remember variable scope? Did they ever teach you variable scope? Please tell me they did. Oh, okay.
I don't think they did.
All right, we're gonna learn about variable scope.
Are you talking about like the range that one type of variable can store?
It's not related to a variable's type. That would be domain, is what you're talking about, right? Like the range of possible integers, for example, that's the domain.
Domain.
Yeah, not the scope. Yeah, scope means something else. So, let me pull you back into Python for just a moment, all right? So let's say we have a nice little Python program. There's a nice little Python program for you. Being able to run code in your head is a very, very, very important skill for programmers.
Oh, wait, I actually do kind of remember scope for local and global. Like that?
We're getting, yeah, it's, I'm going to deepen your understanding of it. Local versus global is like your semester 1 understanding of scope. Yeah.
Oh.
Yeah, in that case, I'm pretty familiar with those.
Okay. So, what's the value of x if we print it?
10?
5.
5.
Oh. Wait.
It's because we're not returning x outside of the function, so x is inside as its own bubble.
Yes. So, we have an x, yes.
I was going to say it's because x equals to 10 is mainly exclusive to that, to its own local function and that function alone, while x equals 5 and print x is running from like the global code, which is exclusive to the specific code of def f bracket.
Yeah. So,
If
we have two x's, right? This is a little less explicit in Python because normally, like, you'd know these were declarations because you'd have, like, you know, the type integer there, right? But when you declare a variable, that variable normally binds to the local scope. I will say the most local scope. So, here, the region of the program that this x applies to is here. The x above applies everywhere because it's been declared in the global scope. It's been declared in main, right? Now, if we are executing code within the blue brace, it's the blue version of x we're using, because whenever you're in a context, you always default to the most local version of that variable, right? So here, x will be 10. However, once we're outside here, once we're back here, X is actually referring to that X. And it's important to understand that these are different and separate variables.
Because one's local to a different function.
Yes. Would you like to know the real reason though? Has to do with how memory is managed. Have you guys ever heard of the system call stack?
Names sound familiar, but not really.
Have you ever heard of the website Stack Overflow?
Nope.
Yes.
Stack Overflow is a great website. You should take a look sometime.
Well,
Stack.
okay.
So like Stack Overflow, the thing that the Stack Overflow website is referring to, is like a particular type of error that can happen to the system call stack, which is very difficult to diagnose. So it's like the name of the website is a difficult to diagnose bug. So that's kind of gives you the flavor of what they want the website to be about. So, stack frames. Your system call stack is a region of memory where every time you call a function, you get a new region of memory placed on the stack. So, because this one is Python, the base frame will be the Python interpreter, right? On top of the Python interpreter, everything in a Python program is inside of the main function of the program. Python just hides this from you, right? So, sitting on top of Python, you have main's stack frame, right? Local variables are stored within the stack frame. So, when I create the X variable and assign it 5, I'm designating a region in the stack frame, calling it, assigning 5 to it, and that's my X variable. When I call function f, I add a new frame to the stack for function f. That's now new memory, right? By assigning x here, I am creating a little region of memory, assigning a little region of memory, calling it x, using it as a variable. So far so good. What happens when the function terminates?
It deletes the whole stack.
It deletes that stack frame, deallocates it. That's right. This thing goes away. We are left with the main stack frame. That's all we have left. So, the value of x is that one. That one's been deallocated, doesn't exist anymore. That is what causes locality. Does that make sense? Now, would you like to see a nifty software tool on the internet that can actually like generate these diagrams for you? Sure. So, let me just put one modifier on this for you, okay? This is function level scoping. Generally, you have either function level scoping or block level scoping. Java has block level scoping, which means basically you get a new scope every time you open curly braces. Does that make sense? So you can have you can do the same thing but with a loop. All right, so. There's this fantastic website called pythontutor.com. Don't worry, it doesn't just do Python. It does Python, Java, C, C++, and JavaScript. Let's do Python for the time being. Ignore the stupid AI thing. So, let's write that exact program. X is equal to 5. Def function def f x is equal to 10. Call the function print x. Visualize execution. So here's a fun little thing, my friends. This thing gives you a slide bar for every step in the execution of the program. And this tells you what the memory is doing. So, next. Oh, global frame. X is 5. Ooh. Oh, f is a function. Love it. Calling f. So, notice we've added a new stack frame for f. Aha! X is assigned 10. Return value of the function is none. Oh look, the stack frame just got blown up. So, print x. What is x? It's 5. Pretty cool, eh? As debugging tools go, this one's pretty dang good, right? In order to debug code, you have to see what the memory is doing. This shows you what the memory is doing. And guess what, folks? It even does object references as little arrows. It's great. So, as I said, it also has a Java mode. Java! So, it does have its limitations, though. So let's even just take this guy, throw that in there, see what it's doing. We'll need a main method too, though. Main. Main. There we go. Person P is equal to new person. So, you know how we required an argument to the constructor? What that actually does, what that actually means, prior to writing constructors, we simply left this empty. But you'll notice that in other object constructors, like the scanner, you provide something here. We now have to provide something here. We need to give a name. Name, Lord Flenderson. Typo in word Flenderson. Yes, I'm sure there is. So. I hope this works. I think this thing expects the class to be called something. Maybe I get it. Class person needs public standing. Oh, no, it doesn't. Oh, maybe if this one's the public one, public, and that one's just a class. Yeah? Try it now. Yeah, there we go. So just make your main class public and any other class not public, and that'll tell Python tutor which one you mean to be the main function, or mean to be the one to execute. All right. The add is kind of annoying. They didn't used to have adds on this. So, there we go. So, you'll see, we have the main frame, we now have the initializer put down, name, Blort Flenderson, right? Age is 0, person instance. Look, see? They've got a thing for objects. And like when an object reference points to something, see? Nice, it's good, yes? Age is assigned 0. You can see that the default value of age is already 0, so really we didn't really say anything by saying age is equal to 0. That being said, it's still good to put it here for documentation. It's like, yes, I intended the initial value to be 0, rather than just let the default fall through, right? Now, what happens when we assign name to name? Oh, interesting. It didn't work. Look, the name here did not overwrite the null. Right? That's because scope. This name and this name both refer to the argument. But within this diagram, we even have a hint about how to fix this. What's the name of the reference to the object? The object references the arrow. What's the name of the arrow within the init frame? What are the values in the init frame?
This and name.
This and name. We know what name is, that's the argument. Oh, that gets rid of the ads, great. We know what name is, that was given in by the argument. So what's this? What is this? This is a reference to the object. So, if we want to fix this, so to speak, this dot name. This dot name requires this identifier to refer to the version associated with the object, not the local version in the method. Make sense? Let's try this again. Oh, come on.
Uh-oh.
Zap! There we go. So, here we go. Age is assigned 0, that does nothing. Let me just zoom out a bit. Click next. Oh-ho! You see? So the green arrow is what line is executing. The red one is what am I executing next. Right? So I just executed this dot name is equal to name, and you can see that the name value in the person instance has been written to Blort Flenderson. Make sense? So, this is really just a fancy way of saying people in Java, for some reason, like to give the argument name the same name as the name that's the instance variable. Up to now, we've gotten around this by saying, like, new name, right? You can also change the name of the identifier, but if you are going to be Java programmers, you must understand that this is a common construction. Make sense? You also need to know what this means. this is always a reference to the containing object. Right? Make sense? So good? So far so good? Thumbs up? Very good. This is a cool tool. You wish you knew about this in Python? Yeah. Like, you can get to this information through a standard debugger like the one built into IntelliJ, but it doesn't like lay it out nicely in terms of like stack frames, you know. I really like this. This is nice. You can show off recursion really easily with this thing. Okay. So that's how you write a constructor. So, let's reconsider our traditional circle class. You can see a constructor given here. Public circle 4, right? Fourth version of circle we've done. Double radius, double x, double y. This dot radius equals radius, this dot x equals x, this dot y equals y. Very good. Then when we use it, circle for C is equal to new circle 1, 2, 3. Make sense? So, advantages of using constructors. 1, the code is more compact since you don't have to call a set method for every individual thing that you want to configure. You can imagine if you needed a different line of code, set x, set y, set radius, as opposed to doing it all on one line in the constructor, that's more work. This complements encapsulation. You can set up your class so that it lets the programmer set the initial values for private variables that are then fixed. Well, actually, they're only fixed for the remainder of the object's life if they're also final, right? If they are just instance variables, other methods can still set them, right? But in a controlled way, like with our age and birthday method, right? Make sense? Good. Yes. So, I was going to say something else, and I forgot. Okay. So, if we consider the classes that we were writing before we knew about the existence of constructors, we could still construct them, right? The act of initializing the object requires calling the constructor. But we hadn't written a constructor, so how are we calling a constructor, right? Well, it turns out that in Java, even if you have not written a constructor, Java itself provides the default constructor. The default constructor takes no arguments and does nothing. You're given that for free, right? So, for example, if I make a new class a class called nothing, a class that contains nothing. If I create a new nothing, nothing something is equal to new nothing. Ha 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 ha. That's not a syntax error, right? I am able to create something from nothing. Ha 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 ha. So, that constructor exists, right? It exists, otherwise you couldn't construct the object. Let's consider this though. What happens if I say, oh, I want nothing to do something? Maybe public nothing. Don't ever do this. System.out.println, do something. Pulling things back to main. Oh, sorry. Yeah, you need to put a string in there. Right. There we go. Now I broke it. So, let's say I modify the constructor so that it now takes an argument. Right? This causes a syntax error. One related problem. I am no longer permitted to call the method or call the constructor with no arguments. And you might be saying to yourself, but come on, they gave us the default constructor. Why? Why can't I now use it? And the answer to that question is, as soon as you write your own constructor, you override the default one. The default one goes away. Make sense? So, if you want a constructor that takes no arguments, you have to put one in. There you go. Now, what do you notice about this program?
It has two constructors.
It has two constructors. That's a bit strange, is it not? As a matter of fact, I can use both of them. Nothing, not nothing, is equal to new nothing. Hello. I can use both. This is legal in Java. Yes.
Can you call them individually? Use one in one section and use the other in the other section, or you have to use both in the same section?
You can use them individually. You don't have to call both at the same time. This program is still legal if I comment out line 4 or line 5. So, this is called Polymorphism. What does poly mean? What does morphic mean? Shaped. Yeah. So polymorphic means many-shaped. Yes.
The name and X for me are still red.
Oh, yeah, that's because that's actually a tag that's inserted by IntelliJ. That's not actually part of the program.
Oh,
See, it pops in automatically. Yeah.
Forgot about that.
Yeah. I mean, it's helpful if you know that's not part of the program, but you know, it's a common beginner trap, you know. So, polymorphism. We have two definitions of the constructor. The thing that selects which version we use is the type and quantity of the arguments. I don't think I've done like function argument polymorphism in JavaScript with you guys yet. That's going to be next week. But oh my goodness, you're going to love this once you've seen how JavaScript does it. Because here, basically what we've done is we have said, you can call this method with no arguments, you can call this with one argument that's a string, and that's it. Nothing else is allowed. Polymorphism, but like we're still like strongly statically typed. We're still, you know, we're not JavaScript, right? But yeah. So you select which one you run by what you give it. Make sense? You can do this with all methods, not just constructors. So. There are many different forms of polymorphism. Technically, any time an operation, you know, executes differently according to its context, that's a form of polymorphism. So, for example, like the simplest example of polymorphism in Java is the addition operator, right? If this operator is used on numbers, what does it do? Yes, it's arithmetic, right? What if it's strings?
Concatenate.
It's concatenation. What if it's an integer and a string? Is that addition or concatenation? That's concatenation. 3 is coerced into a string. What if they're reversed? Same. Fortunately, addition is commutative. Do you know what it means for something to be commutative?
You can do it both ways.
Yeah. It means that A plus B is equal to B plus A. Not all of your basic operators are commutative. For example, if this was subtraction, that's not true, right? So, That is a form of operator polymorphism. We have a particular name in Java for this effect where you declare a method in multiple ways. We call this overloading. We are overloading the method. Okay? If you're the type of person who's taking notes, please make note of the word overloading as you're going to see it on the test.
Well, overloading is a simple word to get the definition for, right?
See, you'd think so, but the test also expects you to know the difference between overloading and overriding.
Oh, well, I know overwriting. That's easy.
Yeah? Okay. I mean, with like classes and such?
Like the words themselves.
Yeah.
The main definition of. But in like code and outside of it.
I will admit that on the test, people usually tend to do reasonably well on the difference between overloading and overriding. But it's still like, you know, just because people do well on a test question, I'm not gonna say, oh, this is an easy one, we don't have to worry about that. You still have to worry about everything in the class. Yeah. Study, 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 study. But this is overloading, right? When you declare a method multiply with multiple different sets of arguments, that's overloading. So, let's consider the following circle class. Once again, circle class. We have how many different declarations? How many different constructors? No, just, I think we're missing a closing brace here. We have 4. Oh, and by the way, did you know that you can stack variables up like that using commas for declarations? That's kind of handy. So, 1, 2, 3, 4. In the first case, how many arguments do we have?
0.
What are the types of the arguments here? Just 1 double. What do we have here? 2 doubles. What do we have 3 here? 3 doubles. So we've got 0, 1, 2, and 3 doubles as our possible interfaces for this method. You'll notice we have had to make a design decision here, right? When we take 2 doubles, those are the coordinates of the circle, and we have the radius be a default value, right? If it's just 1, we're assuming that's the radius, and if it's all 3, it's all 3. But that was a design decision, right? We could have said, if we receive 2, that's the radius and the x-coordinate, and the y-coordinate is the default value. Does that make sense? Not really. Yeah, maybe, no, yeah, maybe you might be able to make an argument for it, depends on the situation, but in general, this probably makes more sense. Documentation, right? You should not have to read the source code to know how to use this, right? The variable names should be informative, and there should be documentation telling you what that constructor is used for. Make sense? Good. So, all right. Looks okay. When we call these, we can create circle classes in all of these different ways. Question?
Is there a way to make it so that you don't have to have a whole bunch of those? You can make like a just one of them that has like a optional amount of inputs with it.
Not in Java. Now, other languages will allow you to do that sort of thing. JavaScript will allow you to do that sort of thing. Not in Java. But I will agree with the general implicit observation you're making that this is kind of clunky, isn't it? This is not the perhaps optimal use of our time, but there's also kind of a hidden danger here. How many times is the default value for radius set? In how many places? Two. We're setting the default value here. We're setting the default value there. How many default values for radius should there be? There should only ever be one. Why? What's the problem with it?
I mean, it's default, so it should be just one basic standard.
So here's one of the problems with this, right? When we write code, one of the things we have to worry about is that code changing, right? We want to write our code in such a way that we can maintain it easily. Now, default values for things are one of the things that you may wish to change, maybe even change frequently, right? It's a highly situational thing. If you if you duplicate that number, you have to remember all of the places that number exists in order to update it. Now, if this is a program that you wrote a week ago, you're probably okay. If this is a program you wrote 9 months ago, you're probably going to forget it. If this is a program you didn't even write, you never knew that to begin with. Right? So, default and initial values fall under the broad category of configuration, right? When we want to set up our programs to be configured, you have one place where you need to change things to configure things. This is a very, very important principle, right? This is even the same reason we write functions. This is the same reason we even write classes and objects. We want to minimize duplication, right? Anytime you take a chunk of code and you copy and paste it to another part of your program, you are multiplying the work it is to fix it if there's a bug in it, right? Bugs are terrible. The hardest thing about programming is fixing bugs. Don't make your work any harder than it needs to be. Make sense? Any questions? Okay. So, we can rewrite this. We can rewrite this in such a way that we are only ever repeating our default values but once. Let's grab this class first. Make a new class. This one was Circle 5, I believe. There we go. Ta-da! So, so the first thing that we have to do is we have to link these constructors with each other. In each of these constructors, we are assigning to each of these 3 instance variables. In the same way that we want to minimize the number of times we've entered any particular number, we also want to minimize the number of times we write to, like the number of places we write to the same memory. So, this guy writes to all 3 of these. There's no way sort of around that one. This one will be our base version of the method. We want the other methods to refer to this one. In order to have one method refer to another, we once again use the this keyword, but this time we're going to call it as a function. Calling it as a function makes it a reference to another constructor. You are only permitted to do so on the first line of the constructor. So, this. So, the version of this, which we gather, or the version of this we use, once again, selects between all of our different constructors based on the number of arguments. In order to use this constructor from here, we provide how many arguments? 3. So, here we're assigning radius 10. Radius is the first one, so we put 10 in there. Then x and y. And we can remove that part. We can do the same here. This radius 100, 100. This 10, 100, 100. So, all right. We're already looking a lot less clunky, right? That looks better at least. If you want to get all that about it, you could even pull those up to be in line. If you want ultra compact notation, which I don't necessarily recommend, but these still need to be documented. Sometimes you see Java people do stuff like that. There we go.
one have like either double x, double the second constructor had either double x or double y, and then we tried making a circle up with two doubles.
Sorry, so you're talking about this constructor?
Yeah, that one.
And it takes, like, we're changing the argument so that it takes double x and double y?
So what I'm saying is which one would prioritize if both the second and third one had two variables in the constructor?
Ah, I understand your question. You're not allowed to. So, that's an important rule about overloading, right? If two methods have the same interface, right? Same number of data types in the same order, that's a syntax error. Java doesn't like ambiguity, right? Basically, you're saying, oh, I got two methods that do this, and Java says to you back, it's like, what, you want me to decide? I'm not a person, I'm a program. I don't do that. I'm not, what do you want me to do, randomly pick one? Go figure yourself out. That's what Java says. So you're not allowed to do that. Good question though, thank you. So, yeah. All right, so far so good. All right. We're kind of still in a situation where we're duplicating default values though. So, in order to eliminate that problem too, you'd have to do basically the thing I didn't like doing, which is that, right? Setting the default values at the top and then not setting it in the constructor whenever you have one of these. One way that you could do it, which would be a little explicit, is to like pass a null value around. But at this point, you're kind of like you're almost better off going like this dot radius is equal to radius, and then just leaving this out entirely. And then that would allow the configuration to all be at the top. But you know, yeah. I had a slight mismatch with the notes where I was like, I want to solve this problem, and the notes are like, but I want to solve that problem. So, yeah, unfortunately. There you go. This is how it recommends doing it. Eliminating the duplicated writing. Make sense? Okay. So. A brief note on UML diagrams. When we are creating UML diagrams for Java and methods have been overloaded, you simply write them multiple times with all of the different arguments, all of the different combinations of arguments. Make sense? Don't want to get into association yet. So, we've covered quite a bit of ground today. Let's do some programming exercises. round off the class. Okay, so,
Sir,
yeah,
for some reason, something wasn't really working with my program for the exercise we just did.
I will come around and take a look as soon as I have introduced this. So, let's consider item B. Your task for the rest of this class, and if you don't finish it, this is your homework. Implement the UML diagram shown on the right. This class can be used to represent one characteristic of a person for the purposes of online matchmaking. A characteristic has a description and a rating from 0 to 10. The default value is 5. You then have a description of all of the relevant methods. Is valid is used to make sure that a rating is in the range of 1 to 10. Ooh, that's a contradiction. 0 to 10, 1 to 10. Pick whichever of those you like. Ugh, pardon me. Call it before you set a rating. The getCompatibility method, it measures the compatibility between this characteristic and another one. Notice that it's taking another characteristic as its input. Yeah, this really isn't the okay, now I can leave section of the class. This is the okay, now we get to try stuff section of the class. So, yes.
It's only one class, right? We're not making multiple files?
That's right. Although you'll need a main method to test it. Yeah. So, get to work. Write me this class. Boom. We'll need it for future examples too. So, once you've written it, save it somewhere where you'll have it for next class. Okay? All right.
Sir, so you said you were going